Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The barrier to rotation about a C to C single bond depends on the steric strain from eclipsing interactions and any electronic conjugative effects. Higher steric bulk around the bond and conjugation increase the rotational barrier. Moving on to the next step. Cyclopentane ring. The indicated bond is part of the ring, meaning rotation about it is constrained by the ring structure itself. The bond cannot rotate freely, it is locked in the ring. The ring introduces angle strain and torsional strain, and true free rotation is not possible. This is not a freely rotating bond in the conventional sense. Moving on to the next step. 1,3-butadiene, central C to C single bond between two sp2 carbons. This bond has partial double bond character due to conjugation, p-orbital overlap between the two double bonds. The barrier to rotation is elevated, tilde 4-5 kcal-mol, compared to a simple C to C single bond, tilde 3 kcal-mol for ethane, because rotating out of the planar conformation disrupts conjugation. And for the final step. Butane, central C to C single bond between two sp3CH2 groups, each bearing 2 hydrogens and 1 methyl. This is a simple C to C single bond with modest steric interactions. The barrier is approximately 3 to 4 kcal-mol, the Gaussian interconversion barrier, which is relatively low and typical for a simple alkane C to C bond. 2,3-dimethylbutane, central C to C single bond between two CH3, 2 isopropyl groups. Each carbon bearing the bond has 2 methyl substituents, creating significant steric bulk. The eclipsed conformations involve severe steric clashing between methyl groups, raising the rotational barrier substantially higher than simple butane. A is ring constrained, not freely rotating. B has conjugation raising its barrier. D has high steric bulk raising its barrier significantly. C. Butane has only modest substituents, CH3 and H on each side of the central bond, and represents the lowest steric demand among the freely rotating single bonds, giving it the lowest barrier to rotation. Therefore, the correct answer is C. Therefore, the correct answer is option C.